If f is the constant focal length of a convex lens and an object is placed at a distance p from the lens, then its image will be a distance of q from the lens where f, p, and q are related by this length equation here. So you have 1 over f is equal to 1 over p plus 1 over q. We need to find the rate of change of p with respect to q when q is equal to 3 and f is equal to 6. There's two ways that you can do this. I'm going to show you both ways. The first method is using implicit differentiation. If we start with the length equation, 1 over f is equal to 1 over p plus 1 over q, and we differentiate both sides with respect to q, 1 over f will be 0 because it tells us that f is a constant. Then when I take the derivative of 1 over p with respect to p, that's going to give me negative 1 over p squared using the power rule, because I can take this p and bring it up to the numerator as a p raised to the power of negative 1. Using the chain rule, we would then have to multiply by dp dq and then subtract 1 over q squared, which is the derivative of 1 over q. Now we solve for dp dq because that's what we're looking for. We're looking for the rate of change of p with respect to q. So when I solve this for dp dq, I'm just going to add 1 over q squared to both sides, and then multiply both sides by negative p squared. So that's going to give me that dp dq is negative p squared over q squared. Now, if we plug in the values that are given, we know that q is 3 and f is 6. So I'm going to put in q is 3 down here. So we have 3 squared in the denominator. We don't directly know what p is, but we can find out what it is by plugging it back into the original equation. If q is 3 and f is 6, we would plug in f is 6 here, q is 3 here, and then we can solve it for p. When we get that, we get p is negative 6. So now we have the value of q, we have the value of p, and so when we plug both of those in, we get negative 6 quantity squared over 3 squared, which gives me a negative 4. So the derivative of p with respect to q would be negative 4. Now, if we solve it a different way, where we just solve for p and then take the derivative like we normally would, since we're trying to find the rate of change of p with respect to q, I want to solve this equation for p. So I'm going to multiply everything by f, q, and p to clear the fractions, and then solve for p, and we'll get p is equal to f times q in the numerator divided by q minus f in the denominator. So now when I take the derivative here, the derivative of p with respect to q, you can either use the quotient rule here, or you can just take q minus f and raise it up into the numerator as the quantity q minus f raised to the negative 1. Either way, when you take the derivative, you should get negative f squared over q minus f quantity squared. And then when you plug in your values for q and f, you still get the same answer, negative 4. You're just going about it in a different way. So both ways you get that the derivative of p with respect to q is negative 4, and the negative sign means that they have an inverse relationship. So as q increases, p decreases, and vice versa. If p increases, then q is going to decrease.